OSPF on DMVPN Phase 2. Rules change. It's not like on Phase 1, because what we need to do recognize now is that Cisco's going to give us a suggestion as to what we need to do in order to bring the environment up and make everything operational. Let's explore that at the command line, but first what we need to do is remove all of our EIGRP configs. So what I'll do is I'll do that real quick here. I'll just cut over to R2 and say config T, no router EIGRP 100. Do show run interface tunnel 0. I just want to make sure that we don't have any configs in here that are going to plague us. So config T, no router EIGRP 100. Config T, no router EIGRP 100. And lastly, on R6, no router EIGRP 100. All right. So let's go ahead and make OSPF light up. So we'll start with the hub, router, OSPF 1, network 2.2.2 will match exactly, and we'll just advertise everything into area 0. We'll make our lives very simple. 10, 10, 10, 2, area 0. All right, do show IP OSPF interface brief is going to tell me that I'm running, but here's our problem. Remember, irregardless of our phase, we're phase 2 right now. We're just not running a routing protocol. We're building OSPF on top of this DMVPN architecture. But notice it says point to point. Now, we can change that. But what is the recommendation in phase 2? Cisco tells us broadcast. So that's what I'm going to do. I'm going to go ahead and make the manipulation and change for interface tunnel 0 to IP OSPF network type broadcast. All right, now let's take a look and see what's going on. So let's cut over to R4. Router OSPF 1, network 4.4.4, area 0, and network 10.10.10.4, area 0. Do show IP OSPF interface brief. Well, again, point to point. Cisco says broadcast. Interface tunnel 0, IP OSPF network broadcast. Now, we've got a problem here. The problem is going to translate to understanding the control plane of OSPF. Now, the moment I have a broadcast environment, it's already been brought up here in the chat, the moment that I have a broadcast environment, I have to be concerned with regard to something referred to as the DR and BDR election. Now, the problem here is the DR needs to be somewhere in our infrastructure where we know it's always going to be reachable. The only device that we have that we can guarantee 100% of the time will always be reachable, as long as our environment is up and operational, is going to be the hub. Excellent call. Now, the hub needs to be the DR, and a lot of people go in and say, well, I'll just set the designated router configuration to 255. Well, that's great and wonderful, but what we need to understand is that the DR election, as we talked about in the confines of OSPF, is non-deterministic in nature. What that means is I can apply that number, but at the end of the day, it really boils down to race condition. Which device comes up? If the device with the higher configuration or the more preferred priority comes up operational after another device has already elected itself as the DR or the BDR, it cannot trump it. There is no coup message. There is no way for it to be able to take over. Therefore, it is non-preemptive and it's non-preemptive, and it's going to be non-deterministic in nature. Now, what we need to do is that the only way to ensure this, and based on Cisco's recommendation, is to change the priority of the interface. So what we're going to do is we're going to change the priority of our tunnels to 0. That's going to say, do not participate in the designated router election. All right, so let's do that. So I'm going to say IP OSPF, am I under the right? IP OSPF. Priority 0. Interface. Well, let's see here. On 5, let's do this. Interface tunnel 0, IP OSPF 1, area 0, IP OSPF network type. What we're going to do here is we're going to say broadcast. IP OSPF priority 0. Go to 6, interface tunnel 0, IP OSPF 1 area 0. And again, notice we're getting the type mismatch. So what we need to do is modify that. IP OSPF priority 0, IP OSPF network broadcast. Now let's cut over to R2 and see what happens on the hub. End. Show IP OSPF neighbors. Notice we're peered. Notice our status is DR other for any of these devices. Now that means our priority is set for 0. So they're not functioning as DRs or BDRs. Now the way I can know that I know this for certain is that I can come up and look at my interface. So I'm going to type show IP OSPF interface for tunnel 0. And what we're going to see is if we scroll up here just a little bit, notice it tells me that my mode is broadcast, and notice it tells me my designated router ID just so happens to be the router ID of the hub, and it's also telling me that it's on interface 10.10.10.2, which tells me it's going to be my tunnel 0 interface. So that means I'm the designated router. Now the important element to this is that we need to understand which devices are going to be any type of BDRs. Okay, 1 second here. I've got a question. Maybe I missed the point. Why are we changing to broadcast instead of P2MP? Point to multipoint. Well, we're changing to broadcast because in the grand scheme of things, the behavior of a multipoint DMVPN is going to be very similar to the behavior on Ethernet. So Cisco recommends that we use that because remember we had the capability of learning all of the information from the next top server. I've done many configurations. I've ran this in P2MP and it works. I'm telling you what Cisco is recommending again based on my exposure to the blueprint and the information that was in the confines of the certification guide for version 5. So I'm not saying that it won't work. I'm saying this is the recommended solution. So again, what we're going to find here is the fact that if we use, the reason being, the explanation is a P2MP generates /32 prefixes, which are going to be matched exactly. We may not actually want that in our infrastructure, so we may want to just be able to route them based on their original /24s or whatever's being advertised. All right? No problem at all. So, looking at this, all I want to do is verify that none of these devices end show IP OSPF neighbors, and what do we see? DR. So if we went through and checked each one of these, everything would be designated as the designated router. Now let's take a look at routing information. So show IP route OSPF 1. Well, let's see, I've got 2, but what's happening? Show DMVPN. Well, I've got everything. Do I get reachability? So ping, let's see, 5.5.5. Well, don't have any reachability here. Let's take a look on the hub. Show IP OSPF neighbors. Well, we've got peering. So the question is why aren't we learning any information? Well, first and foremost, do show run interface tunnel 0. The point is that notice, OSPF doesn't support split horizon, so that's not something that we're going to need to work on. So the question now is what's the issue? What's going on? So, we've got everything, or do we? Show IP route OSPF. I'm only learning 4 on the hub. Show IP OSPF neighbors. Well, here I'm DR. Let's take a look at what's happening on 4. Show IP OSPF neighbors. Okay, full DR. Let's take a look at 5. Show IP OSPF neighbors. Well, this says 2 is the DR, tunnel 0. Take a look at 6. Show IP OSPF neighbors, DR. So the question is what's going on? Show IP route. 3, show IP route OSPF. Remember, we're running the config. The only thing I'm learning is 4. So let's do this. Let's see, clear IP OSPF process. Let's see if that helps us. I'm going to do it on everything. OSPF neighbors. Okay, we're in two-way. Let's see what happens. See if we renegotiate our tunnels or renegotiating our peering. We're in exchange start, which means we're exchanging database descriptors. Now we're operational, full DR other. That's exactly where we were before, right? Show IP route. And the only thing I'm learning is the link to 4. So let's take a look and see what we got going on. Show run interface tunnel 0. Broadcast IP OSPF priority 0. May have to reload this time. Show run interface tunnel 0. So we got priority 0. Network broadcast. 5. Show IP OSPF or show run interface tunnel 0. Priority 0. Network broadcast. Now the point here is show run section router OSPF. Now notice what's going on here. Okay, what did I do different on all of the other devices? Did I use a network statement? All I did was I told it that I wanted to advertise a prefix. Now there's nothing wrong here, nothing's busted. We never advertised our loopbacks, so nothing's showing up in the routing table. So again, this is just demonstrating how easy it is to confuse what's happening in our environment. So when I come over here to the hub, show IP OSPF neighbors, or show IP, oh, that's the wrong device, sorry. Show IP OSPF neighbors. 4, 5, and 6, everything looks good. Control plane's there. I mean, let's look at this. Show IP OSPF database. Now, we're running, we should see type 1s, and we should see type 2s. Type 2s being designated or generated by our designated router. Notice the ID there is 2.2.2.2. It has nothing to do with the network ID. Adrian, the network ID in a single hub DMVP deployment does not have to match. All we have to do is have one. So notice what I did. I did not advertise any of the loopbacks. So when we cut over here and we start looking at what's happening, R4 has one, but R5 doesn't. Show, let's see, show run interface LO0. It's not there. So config T interface LO0, IP OSPF1 area 0. Config T router OSPF1. I'll do it under the interface, LO0, IP OSPF1, area 0, and that should be it. So now if I come up here and I start looking at the database, now notice I'm seeing more information than I was seeing before. So I've got the same entries. I've got 22445566. I only have one DR, so nothing changed here. But what about my routing table? Show IP route, and this is where we're going to see that we have other entries now. We have 4, 5, and 6. So again, don't let the fact that the network ID doesn't match take you down a blind alley. So let's take a look at reachability now. So from the point of view of R4, ping 5.5.5, I have reachability. Let's look at a trace route. 5.5.5, went straight to 5, do show DMVPN, and we still have our dynamic mappings. So again, I'll just check the others. So we'll say trace route to, let's see, what did we do? 555, so 666. Direct to the device in question. So again, if I clear my table, clear IP in HRP, hit enter, show DMVPN, the only thing I have is my static mapping. So if I do my trace route now to say something like 6.6, notice it's going to traverse the hub. That's that control plane mechanism that allows me to register with the NX top server. So the moment that I start originating traffic, that's something that I'm going to want to shoot through. Now the other part here is now if I repeat that test, notice it takes 2 out of the loop. Why? Because what ends up happening is that now I have the entry here that's static, and the one that's important to us is the dynamic entry that's allowing the system to operate. So we've seen what happens. Cisco's recommendation, for whatever reason, is to run broadcast in that environment and make certain that we control who the DR is. Because remember, when we look at this at the end of the day, so let's take a look at it from the point of view of R4, show IP, OSPF, neighbors, I only have one peering. That peering is with the hub. So in other words, when we use this, what happens is that we're going to be in a broadcast environment, but everything, that control plane mechanism is going to have to traverse the hub. Now, when it comes to doing this deployment, we need to also look at the idea of a phase 3 DMVPN and all of the configuration and interoperation that's going to be required to make that work. So what we'll do is we'll entertain that in the next video, and I'll see you guys over there. Bye-bye.